There's something moving through our solar system right now that defies every expectation we have about celestial visitors. And what astronomers are discovering about this interstellar traveler is forcing us to reconsider some of our most fundamental assumptions about physics itself. This episode focuses on 3I Atlas, an object that entered our solar system from the vast emptiness between the stars. When researchers at the Lowell Discovery Telescope captured fresh data on November 5th, they recorded features that add new and fascinating layers to this ongoing cosmic mystery. What their images reveal, and perhaps more importantly, what they don't reveal, is gradually reshaping our understanding of how objects behave in space.
The photographs show a bright central point surrounded by a faint, hazy envelope that astronomers call a coma. But to experienced observers, the most significant feature is actually what's missing from these images. There should be a visible tail streaming away from the sun, created by sunlight pushing against gas and dust, yet none appears in any of the frames. That absence becomes deeply meaningful when we look closer at the rest of the data. Detailed analysis from Dr. Avi Loeb at Harvard shows that this missing tail creates a major scientific puzzle. NASA's Jet Propulsion Laboratory has also confirmed that Atlas is accelerating in ways that gravity alone cannot explain. If this were a typical comet, it would have lost more than 13% of its total mass during its closest approach to the sun. That much material being ejected would create a huge glowing cloud, an unmistakable tail of gas and dust. But our most powerful telescopes, both on Earth and in orbit, see nothing of the kind.
Then, just 3 days later, on November 8th, astronomers captured something even more surprising. Detailed images revealed jet-like structures bursting from the object's surface. At least 7 distinct streams of material spreading out inside a glowing halo hundreds of thousands of kilometers wide. Most astonishingly, some of these jets are pointed toward the sun instead of away from it. That breaks one of the most reliable rules in comet science. Sunlight always pushes material away from the sun, never toward it. So what unknown force could possibly be powerful enough to drive matter against that constant outward pressure?
In October, the Meerkat radio telescope detected faint traces of hydroxyl molecules around Atlas. That discovery was difficult because from Earth's point of view, the object was positioned very close to the sun in the sky. Earlier attempts in September had failed to detect anything, which makes this later success even more significant for astronomers.
To understand why Atlas matters so much, we need a bit of context about other interstellar visitors. Our solar system occasionally receives travelers from other stars, objects flung out of distant systems that wander across the cold emptiness between the stars. Until recently, astronomers had confirmed only 2 of these visitors: the strange cigar-shaped Oumuamua, detected in 2017, and the more typical comet Borisov, spotted in 2019. Both presented big puzzles, but 3I Atlas appears to be something very different, both in size and behavior. A comparison released by the Virtual Telescope Project makes this clear. On one side, a normal comet with a long, bright tail stretching away from the sun, exactly what physics predicts. On the other side, Atlas, a compact sphere with only a faint halo and no visible tail at all. To create the kind of acceleration we're measuring, Atlas would need to eject more than 5.5 billion tons of material. So the obvious question is, where is all that gas and dust?
The measured acceleration is tiny, about 0.02 millimeters per second squared. But in the emptiness of space, even the smallest push adds up over time. In just 1 month, this gentle but steady force has shifted Atlas nearly 50,000 miles from the path gravity alone would dictate. Even more interesting, the movement isn't just straight outward from the sun. There's a sideways component too, almost like subtle course corrections.
For a natural comet, this kind of motion would come from outgassing, jets of vapor that act like small rocket engines. But the numbers here don't fit. Based on its estimated mass, around 33 billion tons, Atlas would have to eject 1/16 of its entire mass in a single month to produce this acceleration. That's 5.5 billion tons of missing material. Yet again, no visible cloud. And that's only the first of 9 distinct anomalies that make this object so mysterious.
First, its trajectory. It entered our solar system almost perfectly along the plane where our planets orbit, within just 5 degrees of exact alignment. Statistically, that should almost never happen by chance. Second, those jets pointing toward the sun, defying known laws of radiation pressure. Third, the combination of its huge mass and unusually high velocity, which doesn't match known models for natural ejection from another star system. Fourth, the timing of its orbit made it visible to multiple planets, but strangely hard to observe from Earth at key moments. Fifth, its spectral data shows an unusual mix of nickel and iron, resembling certain industrial alloys more than natural cosmic rock. Sixth, its composition contains only about 4% water, while most comets are mostly ice. Seventh, its light polarization pattern doesn't match any known natural material ever recorded. Eighth, its origin point in the sky lines up with the same region where the famous 1977 "wow" signal was detected, a signal that some still consider one of the strongest candidates for extraterrestrial origin. Ninth, its color readings suggest internal temperatures that may exceed the visible surface of the sun itself, hinting at some kind of internal energy source.
Now, scientists are being cautious. They're not claiming this is alien technology. They're simply doing what good science demands. When the data refuses to fit existing theories, it's time to test new ones. We saw the same pattern with Oumuamua, which was eventually labeled a dark comet, a name that explained little and satisfied no one. Atlas pushes that mystery even further, with brightness increasing rapidly and an unusual blue hue that challenges what we expect from cold, inactive space objects.
Each natural explanation proposed so far has failed to solve all 9 anomalies at once. And that's what makes 3I Atlas such a fascinating case. If the acceleration can't be explained by gravity or by outgassing, then what's left? What kind of mechanism could create movement without visible thrust? We may soon find out.
From late November through January, telescopes around the world, including Hubble and the James Webb, will conduct intensive studies of Atlas. December 19th marks its closest approach to Earth, offering our best chance yet to detect even faint traces of that missing cloud of gas and dust. If these observations still find nothing, where something should definitely be, then we may be witnessing something extraordinary, possibly our first encounter with technology not of human origin.
Right now, we stand at a crossroads. Either we're watching the strangest natural object ever recorded, or we're seeing evidence of something that could change our understanding of life in the universe forever.
If exploring these kinds of cosmic mysteries inspires you the way it inspires me, then please like this video and subscribe to Grandpa Cosmos. Your support helps us continue this calm, thoughtful journey of scientific discovery together. So what do you think? What could 3I Atlas really be? Share your perspective in the comments. I'd love to hear your theory.